Hello and welcome to this presentation about the structural characteristics of the relational database management systems. Now, these databases go back all the way in the idea to 1970, so they're as old as I am, and they were invented by this guy, I love his name, Edgar F. Codd. First proposed them in 1970. Now, it's an incredibly complicated system, or complex system I should say. There's a lot of moving parts to it. This is just a very brief overview of the things mentioned in the study design. So students can identify the key elements of a relational database. I don't even know that we're going to go as far as the key elements, the ones that are mentioned in the study design. We're going to be talking about tables, primary and foreign keys, and queries. Now, a query, it's worth saying, is not just getting information back. When you're updating it, when you're deleting it, when you interact with a database of this nature, you're doing it via a query. So pretty much everything is a query. Well, a relational database management system is software that manages data and it's organised according to the relational model. Now, relation in this sense actually means a table. So I'm not quite sure why that term is being used for a table. I don't have that deep an understanding of it. But I think your basic unit of currency, well, your three basic units of currency, you've got fields here, also known as attributes. You've got rows here, also known as records, and you've got them all bundled together in a table, and your database can have multiple tables. So you connect to the database once, and then you can interact with the tables. And one of the beautiful things, I don't actually cover it in the text of this, is that you can set up a user who has, say, read access, or they can read and update but they can't delete, or you can actually be very specific about who can access what and who can control what, and it's an incredibly powerful way to manage data. And basically any website you go onto where it remembers you, where the detail isn't stored on your local device, is on some sort of database. And the most common one is SQL, although there are other ones. The tables organise in two-dimensional structure, rows, which I've just talked about. So each row there represents a list of things on my little page. Actually, I've got my little page here. So this is a page I have set up for myself so that I can quickly go to stuff that I'm interested in. I've got my personal ones, I've got my work ones, and I've got all of them. And they all live in the database, so they're not hard-coded in at all. They exist in the database so that it's easy for me to update them from wherever I am, and the page will change its behaviour. So each record is a different item on that list. And the columns, also known as fields or attributes, represents a specific characteristic. So if we look here, that's the ID. We actually come into that. That's called the primary key. That's the visible field. That's the text that will be visible on the page. There's the URL. And then I've got this field called list about whether it's for work, for both, or for personal. So that's what's stored in there. Here's an example. A student table might contain columns for student ID, first name, last name, date of birth. No two columns are going to be named the same thing. They have to have individual names. So keys are an essential part of this. So the first one we need to know about are these primary keys. You'll see here that no two IDs are the same. Now I have these set up as auto-incrementing. They can't be the same and they can't be empty, so every time I create one, it will pick the next highest number. It won't fill it in my SQL, so if I were to delete 8, it won't put something else in the space of 8. It will put it at the end of the list. I'm not sure if that's true of all systems. And a foreign key, it would be if I had a column here which referred to its primary key in another table. So if I had a second table, then I might have a attribute in this that referred to what its ID was there, so that I could easily refer to it. I could get that value and then call that table using that. So this is the space in which I write my SQL queries. This is actually on the 42 Penguin server, and as you can see, it's got a little bit of structure for you there. You can select what type of query you're going to write. You can ask it to show the query again. You've got the fields there to choose from. This is kind of to help you. There's a whole other presentation about about types of query design, which you would probably be better off watching after this. But here is one of the interfaces that you can use to write a query. So let's look at some queries. So up here we're saying select, so that's saying, hey, I want you to go get me some data. I'm saying what fields I want it to come back from, so it's going to give me back 4 bits of data from the table that's called students. Where means basically I'm going to filter it, only do it where this field equals that. In this setting, even though it's asking a question, it's only a single equals, unlike in lots of programming languages where it would be equals equals. And order by last name first, and then if last name is the same, order by first name. And so this will give me back a list of year 10 students. You'll notice here in the illustration that it's got slightly different field names and they've got talking marks around the 10. You can actually use talking marks. They use these little ticks. They're above the tab key. I can never remember what they're actually called. I think of them as a tick, but I don't think that's a proper name. So let's have a look at this next one. This is an insert. So we're adding a new student to the database. Insert into students, so that's saying that's the table we're putting it into. We're adding the following fields, so you list the fields, and then we're adding these values. So 1, 2, 3, 4, 5 is going to be their student ID. First name is Emily, so it's by their order in that list. Now it points out here, and I think this is pretty sensible, that student ID might very well be auto-incremented. You probably are not manually creating that, because I wouldn't trust myself to be adding the numbers. I just let it auto increment. Okay, we can also insert multiple values. So in this one we're inserting into enrolments. We've got 3 attributes we're adding, and as you can see we've actually got 3 sets of data that we're adding in. So you can have one query that creates multiple records. This update, so if you're editing something, this is called an update. So we're updating students, so that's the table. We're setting the value of the year level attribute to 12, where the student ID equals 1, 2, 3, 4, 5. If you don't use a where, you're going to end up changing everybody's attribute. Now I actually do this reasonably often. I have a table that's set up for your directories on Citadel, for those of you who are students of mine at Geelong High, and at some point in December and January I go through and I say update the year level to 10 where it equals 9. So I'm turning all the 9s into 10s. But I think I want to work it. I think I delete the year 12s first, and then I turn the 11s into 12s and the 10s into 11. You have to be quite careful when doing mass updates like this. You can delete. Delete behaves exactly like you'd expect it to. So we're deleting from the table called enrolments, where the student ID equals this and the subject ID equals that. Delete is permanent. Be careful. This actually recommends, and I see this advice quite a bit actually, just marking records as inactive rather than full-on deleting them. I suspect you've got to be mindful of privacy policies. In some situations I suspect you're obligated to keep the data. In some situations I suspect that you are obligated to delete it. I think it would depend on the situation. Alright, moving on. Now this is what's called a parameterized query. You've got to be really careful with queries, particularly when you're using data from a user, because if they can get something in MySQL injection where they can actually do considerable damage to your database. And one of the ways you can protect yourself is, rather than just running a plain query like I've had before, you can include the values. So you're only getting, say, the student ID, and that's going to appear where that question mark there is. So you're actually you're kind of having a step of distance between the user and the query that you're doing, and that gives you some protection against malicious attacks. So that's a parameterized query. I confess that I don't write parameterized queries. I write plain queries, and then I get AI to turn it into parameterized queries, because I always seem to mess them up. You can in fact make a query from different tables at once, and have them joined together. So even if you don't have a foreign key, you can say, hey, find their ID from here, and then I want you to use this ID to get something from this table, and then I want you to use that to get from another table. So this is choosing first name, last name, year level, and enrolment. You'll notice it's S dot and E dot. Well, these are enrolments, which are E on, and it's specifying what the data is called depending on where it's coming from and how it's combined. This is one of the reasons why we want to take time to write our database queries. They can get quite complicated. All right. Oh, that's why that's the end, because that's in fact the end of the presentation. So if there's things you need to remember, and there are, tables. We need to remember table is kind of where a whole lot of related information is stored. We've got rows, we've got attributes, we've got keys, and we've got queries. So that's most of what you need to remember. I hope this has been reasonably clear.